Hello, Year 11s. This is a presentation for you. It's on polar form of a complex number. And polar form of a complex number is mainly studied in exercise 16E of your textbook. Now I'll try and explain briefly the background to it. Now, previously we've explained the location of a number on an Argand diagram in this way. We've said this is the real axis and this is the imaginary axis. And so we have a point up here. So this is x plus yi, that is x real numbers across and y imaginary numbers up or down. Now there is another way we could define this point. Now if there's the real axis, there's the imaginary axis, and here's our point up here. Well, what about if we figure out the distance in a straight line from the origin to our point, and what about if instead we define for the angle from the real axis up to our up to the distance. Now this way is saying across and then up. How far across do we go, then how far up we go. But this one says what is the distance from our origin to the point in a straight line, and what is the angle between the positive real axis and the line that goes straight to the point. Well, these are both the same way of these are both different ways of defining the same point. So we could say that x plus yi is equal to r comma theta. Alright, now this is polar form, this is rectangular form. Alrighty, let me give you some examples to show you how you might convert from polar form to complex form. Okay, so what we've got to do is to find the polar form of 2 plus 2 root 3i. Now, let's imagine where it might be. So here is the real axis, here is the imaginary axis, and that goes 2 across and 2 root 3 up. So if we're finding it in polar form, we need to find this straight line here. Now, this point in a straight line from the origin, this distance is sometimes called r, or it's occasionally called the modulus. So if we had to work out the modulus, what we could say is r is equal to 2 squared plus 2 root 3 squared. Now 2 squared is 4, 2 squared is 4, and root 3 squared is 3, 4 times 3 is 12. And that's just using Pythagoras' theorem. The square root of 4 plus 12 is 16, square root of 16 is 4. So the distance that our point is from the origin in a straight line is 4. Now, the argument, or the angle between the positive real axis and our line, is often called the argument. The argument. Now, if we have to figure out the argument, we can say, alright, well, theta will be equal to inverse tan of 2 root 3 over 2. So that would be inverse tan of root 3. Now that would be pi over 3. So 2 plus 2 root 3i is equal to 4 pi over 3. Alright, what about if we had to do this as 1? What about if we had to find the polar form of 2 minus 2i? Well, let's figure out where it is. So, if there's the real axis, and there's the imaginary axis, now 2 minus 2i would be 2 across in that direction, and 2 down in that direction. So, we'll have to find the modulus and the argument. So if we say the modulus, let's see, r will be equal to 2 squared plus minus 2 squared, which will be 4 plus 4 square root of 8 to root 2. Okay, now the argument, now let's see. Now usually when we have the angle from the positive real axis around anti-clockwise is a positive argument, and around this way is a negative argument. So our argument will be negative. And if we say, alright, well, theta will be equal to inverse tan of, let's see, 2 over 2, where that's the opposite side and that's the adjacent side. 2 over 2 is 1. The inverse tan of 1 equals pi over 4. Alright, so that would mean 2 minus 2i in polar form be 2 root 2 and minus pi over 4. Alrighty, well I hope that helps a little bit, and I'll see you in class where you can ask any questions.